Good morning, everyone. Welcome to KubeCon San Diego 2019, day 2. How's everyone doing today? This morning, yeah? Awesome, awesome. Got some coffee? I'm very caffeinated, so whew. So let's get started. Today we'll talk about binary authorization in Kubernetes. How many of you are familiar with the term binary authorization? Raise of hands. Okay, like half the room. Good, good, good. For the rest of you, I'm excited for you to learn about what this means, and hopefully this will help you in your workflows. So let's get started. I'm Aysylu Greenberg. I'm a senior software engineer at Google. Throughout my career, I've worked on a bunch of infrastructure projects such as search infrastructure, developer tools infrastructure, Google Drive infrastructure, and these days I work on Google Cloud Platforms infrastructure. And I'm the eng lead of 2 open source projects, Grafeas and Kritis, which we'll talk about today. And you can find me on Twitter. And today I'm presenting with Liron Levin, who is the chief architect at Palo Alto Networks. And he's one of the biggest, most valuable contributors to both Grafeas and Kritis projects. His contributions were instrumental in launching 0.1.0, Grafeas and Kritis, and he's been just a huge help throughout the whole time. So today the talk will be in 4 parts. First, we'll talk about why we need binary authorization, kind of to motivate why we're even talking about this today. Then we'll talk about how to improve the security posture of your Kubernetes cluster. Then we'll talk about exciting new open source projects, Grafeas and Kritis, and how they fit into the need for binary authorization in Kubernetes. And finally, we'll have some fun and see a cool demo that Liron prepared. So let's get started. So how many of you are familiar with the term software supply chain? Okay, about a little more than half of the room, great. So for those of you who are not familiar, software supply chain basically describes the whole flow of the code from the time the code is submitted by the developer to the code base, and then it's picked up to be built and tested by the continuous integration pipeline, and then it's deployed to Kubernetes by the continuous delivery pipeline. Okay, so now that's the kind of in theory how it's all lined up beautifully into nice steps. So let's talk about the reality.
So this is like a sample cluster we have in our test environment. I have Istio installed, I have Kubernetes installed, and I have some sample application. Now, when I look at it, I started to ask myself several questions. So just by looking at the cluster, do I know really what kind of images are deployed right now to my test cluster? And can I tell if all those images will pass the required QA testing or DevOps testing, okay? And is one of those images are impacted by, I don't know, a severe security vulnerability, for example, the Apache Sprout remote code execution, which cost millions of dollars. Now, just by looking without doing anything, I don't have this information about my cluster. So what can we do? So this is the software supply chain we saw, but maybe we're missing an accession component, okay, that will authorize and verify stuff before they get inside our production cluster. Okay, so this is what we want to do. So what are the use cases for binary authorization? First, we want to ensure that images inside our test cluster or production cluster will be signed by trusted authorities. Authorities can be a QA, it can be DevOps, and it can be any security tool. But you want to ensure that somebody approves an image before it goes inside production. Second, you want that your images will pass some restrictive security criteria. For example, no critical severity unpatched vulnerability, okay? You want to ensure that. And finally, you want to continuously monitor your inventory and data inside your production cluster and verify those kind of security issues doesn't reoccur, okay, over time. So, luckily, there are 2 open source projects that together can implement and fulfill and solve those problems. So first, Grafeas, which is an artifact metadata API. In technical terms, this is like a way for you to put information about stuff that are running inside your cluster. And second, Kritis, which is a deploy time policy enforcement solution for Kubernetes. So this ensures that nothing vulnerable or non-compliance will get inside your cluster. So to understand how it works, let's go together over a very simple example of creating a pod in Kubernetes cluster with Kritis and Grafeas. So as you all know, first we have the Kubernetes API, okay? So when you do kubectl create pod, kubectl calls the Kubernetes API, which is an HTTP request. Then we have Kritis, which is an admission control component for policy enforcement. So Kritis is an admission webhook for validating requests. Okay, this is a standard component inside Kubernetes. So Kubernetes API call Kritis to validate the pod creation request. This goes to the validation webhook, which next called to the image security validator component, okay? So this component is in charge to verify that the pod that you're going to create, okay, is compliant to the policy. Now you ask, where is the policy? So in Kritis, the way we implemented it is to put the policy as a CRD, a custom restore definition. So Kritis policy is a CRD, meaning that like we use, a CRD is an extension to Kubernetes where it enables you to put like your kind of, like your policy or anything inside Kubernetes and query Kubernetes to fetch them. So to understand exactly what is the security policy, let's quickly go over an example Kritis policy, okay? So a Kritis policy has a kind. In this example, this is an image security policy because we want to verify the security of an image. Next, it has an attestation authority names. Those are the authorities that can sign over images and that can like approve images that are going to be deployed inside your cluster, okay? We have an image allow list. Now, usually, you don't want to run security checks on all the images in the cluster. For example, for infrastructure images like Istio or images from Kubernetes, so you don't want to verify them for vulnerabilities. So we also enable you to whitelist them. Next, for the important part, we have a requirement for package vulnerabilities, okay? So Kritis gives you two types of properties that you can specify, and this is specified per namespace, okay, per Kubernetes namespace. So it gives you the ability to say what is the maximum severity of a vulnerability that can be inside one of your images, okay? In this example, the maximum severity is high, meaning anything above high will be rejected. For example, critical severity vulnerabilities. The second property is the maximum fixed unavailable severity. So not all vendors patch all vulnerabilities. Maybe because the vulnerability is low severity, maybe because it's not applicable or not exploitable. So what will you do when like you have a vulnerability, but you don't have a way to patch it because an upgrade of the package will not work? So for this, we provide you this property where you can just define what to do for those cases where there is no solution for the vulnerability, okay? No way to update it. Finally, because although it's not the best practice, you can't patch all vulnerabilities in the world. Sometimes you don't have enough time. Sometimes there is no solution for the vulnerability. So we also enable you to specify a whitelist of CVEs or vulnerabilities, which you can say, I will fix them later or I will not fix them at all, okay? So now that we have a good understanding of how the policy looks like, so we get the policy from Kubernetes API, and now the policy is inside the image security validator. Now, in Kubernetes, there is no notation of vulnerabilities or data about images. There is also only the specification of the pod. So from where do we get this data? So for this, we have Grafeas. Now, Grafeas is an amazing project. It's a community-driven project to have a uniform way to have metadata about stuff that are running inside your cluster. It can be images, vulnerabilities, deployments, and much more. So, as I said, it's a uniform way to audit what goes inside the software supply chain. Everything cloud native goes inside Grafeas, and it has a common protocol and APIs to do all that. So, let's shortly understand how Grafeas metadata store works. So in Grafeas, the first thing we have is it's called nodes, okay? And think about it as specification that describes a piece of metadata, okay? For example, vulnerability is a metadata. So it has a kind, okay? It has a detail, for example, which package is impacted by the vulnerability. It has a mean affected version, so from which version this vulnerability is applicable, okay? So this is a node. And there can be many other types of node. It can be an attestation authority node, meaning this is an entity that can sign stuff in my cluster, okay? And it can be deployment, and it can be build history, and it can be many, many other more properties that are continuously expanding. So those are things that security tools, stuff at Kubernetes, and other tools can use to understand information about stuff that are running inside your cluster, okay? Very cool. So the second thing we store in Grafeas is occurrences. And occurrence is the actual instantiation of a node. For example, vulnerability. So vulnerability has no meaning by itself. Like, it has meaning, but it doesn't have meaning by itself if it's not applicable to anything. So, and notice the applicability of something inside your cluster. For example, vulnerability. So it has a kind, okay, and it has a resource. And the resource in our case for a vulnerability is the image hash, okay? So you can say this vulnerability impacts this specific image, and you can also specify how this vulnerability impacts the image. For example, what is the affected version? So in my image, I have a specific package installed, which is a specific version, and I can say this inside Grafeas. And next, I can also say what is the fixed location. So what will happen if I upgrade, like what is the minimum version I need to upgrade my package to be non-vulnerable, okay? So this is like how we specify vulnerabilities inside Grafeas. And it can be, there are many other types of occurrences. It can be the package, it can be remediation, a build history, and many other interesting artifacts. Okay, so now that we have good understanding what is Grafeas and what is its role, so the image security validator inside Kritis calls the API to fetch the metadata, okay? And in the open source implementation, and again, everything here is existing open source and you can use it. So in the open source implementation of Grafeas, we have 3 types of databases that you can use. You can use an in-memory database, you can use an embedded database using BoltDB, or you can use Postgres, okay? So all of this is already implemented. So we take this data from Grafeas, okay? Now the interesting question is, who pushes security data to Grafeas? And the answer is security tools. For example, Twistlock or Prisma Public Cloud. So we scan your images or scan your host or scan other cloud native components and push all this data to Grafeas. And there are many other tools like container security analysis and many other existing tools that can push data to Grafeas. Okay? So now that we have a good understanding of how Grafeas works, let's see a demo. Okay? Are you ready for the demo? Woo! Good. Okay. So the first thing I'm going to do is to install Grafeas. Now, the demo I'm going to show you is already written. It works perfectly. It's inside the Kritis GitHub repository. You can use it today to install a full instance of Grafeas and Kritis using Helm chart in your currently only in your GKE cluster, but very soon in any Kubernetes cluster that you're using, okay? So everything here works, which is good. So first thing we're going to do is to set up Grafeas, okay? So hopefully the internet will work. Okay.
We're good on time.
Okay, we're good on time. Yeah. Okay, so maybe the internet will not work. Okay, so this is an internet problem, not our problem. Grafeas works perfectly. Okay, people can use turn off. Okay. So this, what I need to do now is just run a very simple script that install Grafeas using the Helm chart in my GKE cluster. Okay, so we can see that Grafeas is running. Okay, so we get the pods, and it's in the default namespace, but we can obviously modify this just for the demo. So we installed Grafeas. Now I have a database that will store information about stuff that are running inside my cluster. The next thing is to set up Kritis. Again, another Helm chart that will install Kritis and will automatically connect it with Grafeas. Very cool. So again, it needs to create a certificate to create trust between Kritis and Grafeas, which is fine. It will take a few seconds. Internet problem, not my problem. And okay, that's good. That's okay. So it's running. Excellent. Now I have Grafeas, I have Kritis. What is missing? So I need to set up a security attestation to enable Kritis to sign over stuff so that like it knows who did what. So let's set up Okay, so let's create the attestation authority. So I need to create an attestation authority to enable Kritis to sign over images and information that's going to be deployed. And finally, okay, so I'm going to deploy the policy. Now, this is the policy I'm going to deploy. This is the same policy I showed you a few minutes ago. It has the Kritis authority. It has the maximum severity. The maximum severity in this policy is high, meaning something with critical severity will get rejected. It will allow any vulnerability that doesn't have a patch, which is, it's not reasonable security, but this is what we're going to show you today. And that's about all. So let's create, with kubectl, let's apply the policy, okay? Cool. So we apply the policy, it works. And finally, okay, now we're going to scan some images. I'm going to scan 2 images, Jenkins and Nginx. Now Jenkins is very good and they have a very good security pipeline, but I'm going to scan a very old Jenkins instance. So let's scan the images. So what you see here, okay? So I'm scanning the images using TwistCLI. TwistCLI is Twistlog tool for scanning vulnerabilities inside images. So as you can see here, this is the result, and they don't look good because I have like very large zoom. But I have 6 critical vulnerabilities inside Jenkins, okay? And I have 2 medium vulnerabilities inside Nginx. Now, according to and this tool also publishes everything to Grafeas, the nodes and the occurrences. Now, according to this configuration and the data that I pushed, if now I'm going to apply a pod, the Nginx pod, okay? Will you think this will work based on the lecture? Yes or no? No, I mean, will it get rejected or approved? Approved, okay. So Nginx, approved, good, okay, but it doesn't mean anything because even without us, it will get approved. So, but let's see what's going to happen when we do it with Jenkins. Approved or reject? Reject, okay. No, yes, it's rejected because the admission control Kritis validation webhook denied the request because it found violation. If I will look at the log, I will see all the violation that happens, and I can also look at Grafeas, call Grafeas API to verify all the violation and see what's really going on and what can I do to fix all that. That's good. And that's the entire demo. Okay, so it works, you can use it today, and that's all. Cool. Okay.
I'm so glad this demo worked.
Yeah.
It's always the scary thing with the live demos. But so what's next for Grafeas and Kritis? So let's talk about the roadmap. So for Grafeas, first of all, we would like to add new metadata kinds that help you express for your CI/CD pipeline, for your software supply chain, all the necessary information that you could store. So some of the new metadata kinds that were proposed by the community are licenses, test information, which test passed, failed for any given image, artifact, static analysis for any kind of static analysis you would like to run on your code and record that information, and also in total link attestation. Periodically, we'll have community calls where we discuss this with the community, we discuss the representation, so on. So if you're interested in contributing more metadata kinds or commenting on this, please tune in the community calls. Now, also, we'd like to move our server 0.1. I believe it's 2 now, the micro version. We'd like to move it to 1.0 version. And it's a little thing about the 1.0 version. So basically, what does it mean for it to be 1.0? It's production ready. It's proven by in production that it's working. Internally, we have our own implementation in Google, and so the open source version, we would like to get it there as well. And this means using the V1 protos and also ensuring that it's just running and stable and you can trust it. Now, we would like to move towards larger community contributions, community participation in this. So this means that we'd like to have community members step up as maintainers for client libraries for each of the languages. Currently, we have libraries for Go, Java, Python, Ruby. And if you are using those languages, most likely you're the most knowledgeable about all the different pitfalls, all the different edge cases, which it's not quite working as expected. So if you'd like to step up to maintain them and make them work the best possible way, then we would welcome that. And also, we would like to have the reference server implementation move to 1.0 with the community help. As I mentioned, internally we use our own implementation of Grafeas, and I use sometimes the standalone version that Liron presented in the demo today. But those of you who will be using it all the time will be a lot more knowledgeable and can contribute a lot more different ideas on how to make this robust and stable. Now, what about Kritis? So for Kritis, we would like it to become production-ready, highly available Kritis. By that, I mean if Grafeas is unavailable at any point, making sure that Kritis can still either allow or reject your pods and have a very well-defined fallback policy that you as the user of Kritis can define yourself. And also providing interoperability between binary authorization on Google Cloud Platform, and the open source Kritis. So making sure if you're a user of the Google Cloud project and then you start using open source or vice versa, that you get a seamless experience across both. And binary authorization team is working on this. There is a 0.3.0 version coming up where this work is being done to ensure interoperability. And finally, we would like to have more expressive policies so that you could use any of the metadata kinds stored in Grafeas and then be able to write policies based on those and have the deploy policies, deploy verification based on the metadata you actually care about, whether it's ensuring that build was signed by the appropriate entity, whether you want to make sure that at least 99% of the tests have passed, or the most important tests, maybe all the unit tests, but some of the flaky functional tests are okay to skip, and so on. Opportunities are limitless, and all the different combinations are infinite here. Cool. So if you're interested in learning more, there is the tutorial on deploying standalone Kritis with standalone Grafeas that you saw in this demo today, and so you can start running it today. There's the Grafeas project is developed open source first, so you can find it on GitHub. Kritis project is also developed open source first, so you can also start contributing to that. There is 3 mailing lists that we have, which are Grafeas users for anyone who's using it, Grafeas dev if you're interested in contributing to Grafeas as a developer, as a contributor maintainer, and then Kritis users. So please join those mailing lists and stay up to date on what's happening in that community. And we also have a Twitter account for any questions or any kind of big updates that we have. So to conclude, I would like to ask a question. How many of you are interested in either trying out Kritis and Grafeas first? Okay. How many of you are interested in contributing or stepping up as my director? Okay, nice, very good. Well, thank you so much. My clicker stopped working at the producer.
No,
oh, maybe that's all. No, thank you so much. And let me check how much time we have. We have about 10 minutes to take questions. So yes, lots of hands. Let's see. Let's start from right side to the left, and we're just kind of scanning. Okay, Aidar, go ahead. The question is, do we plan to donate the project to CNCF? So that's a great question, and we've kind of been asked that for the past year since I've stepped up as the maintainer of the project. It is an interesting idea. Right now, the project is just in very early stages. We're still trying to figure out what is the most necessary thing for the community. So we are considering it, but it's probably not going to become urgent anytime soon, just to figure out the fit. Okay, you in the back? Mm-hmm.
I've been to sessions on OPA, a couple of sessions, and I see a little bit of overlap between what Grafeas and is doing. Where do you see this go? Can we use them both together, or is it actually two different concerns? Mm-hmm.
Thanks for your question. So great question. So for especially the last part I mentioned about the roadmap for more expressive policies, that's something that has come up, and we are evaluating actively whether OPA is a good fit. It has been brought up by several members of the community, so it's definitely in the back of our minds. We are thinking about it, and if any one of you are experts in OPA, would welcome your contributions and your ideas for this. Thank you. Let's see. More questions, and we'll start scanning. Okay, you in the back in the black shirt, and
yeah, so
okay.
I saw that you have the ability to add exceptions to policies around an image level, and I was wondering if you had the ability to add exceptions based on like a sub-package within an image.
Mm-hmm. So just to repeat the beginning of the questions for those of you who couldn't hear it. So we have some allow lists, the exceptions in image security policy. Could we add more of different types of allow lists? Again, open to that. That's definitely something that I could see being useful to the community, to the users. So if you have specific use cases for which you would, definitely going to be using it, please chime in, open GitHub issues with a description of what you're using, and then we can discuss it with the community and add that. Definitely open to modifying this and adding new types of policies. In the back, please. Yes, you. Come
on. So I think Grafeas is great, but one of the problems is this is all data, right? This is kind of what's going on in your system, whether like here builds and deploys and stuff like that. But is there any kind of talk of some a dashboard, some kind of visualization of actually pulling together all this information so you can have conversations about it, other than going to any of the commercial vendors and having to use their products that kind of wrap around Grafeas? Mm-hmm.
Great question. So. The focus of the Grafeas is to provide the API and the spec of the metadata kinds, and then have all the different vendors in the CI/CD pipeline integrate with it. And so the scope is specifically around providing good, solid API that is easy to integrate with. It's also agnostic of the storage backends, so we don't dictate what storage backends you should use. And then anyone who wants to build UI on top of that, they're welcome to. The thing is that different Grafeas and Kritis users will have different needs for the kinds of queries they would like to run on top of this. So Grafeas API is just, very straightforward CRUD API for retrieving nodes and occurrences and asking some questions. And then if you'd like to write higher level queries on top of that, that's something that is on a case-by-case basis. But again, if the community finds common needs across the boards that should be implemented, that's definitely something that we should be discussing. Thank you. Yes, question.
Yes, I noticed the tool is focused on people validating the pod before deployment of Kubernetes. It seems to be driven by effectively a policy which. Sorry, I noticed the tool is effectively validating before deployment of the pod at the Kubernetes at potentially the customer site. However, it seems to be driven by a text policy. Is the text policy in any way itself protected against unauthorized modification that might allow a pod that should not run to run? Mm-hmm.
Thank you for the question. Do you want to take this, Liron? Since I've been answering.
Just Kubernetes. You can prevent this with Kubernetes policies for authorization. User this can touch that type of object. But again, it's not it's a concern for Kubernetes that unauthorized authorities will modify a policy.
My concern centers on company that produces a product that ships as a large number of microservices, and I'm looking to validate the provenance of our microservices all the way to the customer site. And many development team can produce microservices, but their microservices should not appear at the customer site, only the officially tested, validated, whatever. And it seems like I, with proper knowledge, could fake a microservice that goes to the customer site that has a policy that lets it run, even though it's really not something that's officially built.
So I think the question is more for Kubernetes authorization, because the objects here are per namespace. So if you have misconfigured your Kubernetes configuration to allow users to modify namespace that they shouldn't have.
Well, no, I was thinking if the policies themselves were signed and checksummed so that Kubernetes said, no, this policy doesn't have the right key, then we would ignore it. We would fail outright. You've got a bogus policy, don't use it.
So there's other ways to look at it. So one way is at the Kritis policy, right? The custom resource definition, which is, exists as it is. It's an extension of the Kubernetes API. Another thing you could do is store either with existing metadata kinds in Grafeas or add new metadata kinds where you're basically signing those things and requiring all the different CI/CD pipeline steps to sign it and verify it. So before it even gets to deployment step, it would be verified along the way. Thank you. Questions? Let's move to this side of the room. Yes, you in the back, in the middle.
Currently, Kritis only runs on GKE. Is there plans on your roadmap for adding support for other cloud providers or on-prem Kubernetes for Kritis?
Great question. Thank you. So we welcome community contributions. I personally just working on GCP infrastructure, work a lot with JKE. But again, very open to community contributions, whether it is to run a Minikube or any other Kubernetes implementations. Yes, go ahead.
So, what's going to happen box authorization? Is it going to install this automatically in my cluster? Because I know there is like a checkbox while creating the GKE cluster.
Could you repeat the question, please? It went in and out, the voice. Yeah, sorry.
So while creating the GKE cluster in the console, there is like a checkbox for binary authorization. Just wondering what's going to happen under the hood when I just check this box.
Right. So I believe you're talking about the binary authorization on the GCP, which is the internal, like the proprietary version. Kritis is the open source version of that. And so it will be running separately and it won't be under that UI. But there is work happening to improve interoperability across the board. So yeah, so that's the plan. Thank you. In the back.
How flexible is Kritis to work with different APIs? And how flexible is Kritis to work with different APIs besides Grafeas? Or does Grafeas represent the API protocol that Kritis needs to use?
So I'll answer my version of the answer, and then also I'll welcome Liron's experience with it as well. So generally, Kritis doesn't really require Grafeas. It just needs a way to store the metadata and then retrieve it. So if you'd like to, right now it's implemented to retrieve that data, the metadata for artifacts from Grafeas, but if you'd like to use it without Grafeas, again, it's possible to implement this, and contributions are welcome for that as well. And Liron, if you have...
I actually did it, I did it for Grafeas. Before that, it was only for Grafeas GKE. I did the implementation to use your own Grafeas instance. So I think it's completely extendable. You can write it. But I do think that Grafeas is a good source to have a clear API for vulnerability data, for deployment data. So I would just extend, if you want to do more stuff, I would extend the policy language in Kritis and the stuff you can store in Grafeas. But I think it's good as a community that we have a clear API to store stuff, because then we can have interoperability between multiple tools. So this is just my opinion. But again, she's on the project, so.
Thank you.
Okay.
Thanks. Okay, let's see. I have no idea how we're doing on time because I haven't checked. We have 5 more minutes. Perfect. Okay. More questions. Keep them coming. Yes, go ahead. Great question so far, and I'm happy to repeat as well the question, or you can get some exercise this morning.
Thank you. So currently, it's running as an admission controller. So it only scans at. But it needs to be every day.
It's a good question. It says what I show you a diagram only for a small portion of what Kritis does. It has a cron job that continuously monitors the thing. And so I just wanted to simplify how it works. Technically, it does multiple stuff, and you have a cron job that I just want to repeat the question. He asks what happens over time. So in the demo we showed before, we only showed what happened when you created pod, but technically Kritis continuously scan your environment, verify vulnerabilities, and then you can decide based on the policy what to do. Do you want to block everything? Do you want to continue running? Do you want to get an alert? What do you want to do exactly? So it gives you this, we just didn't show it.
Okay.
Because it's a little bit more complex.
Thank you.
Thanks. Okay, on the left.
Okay, so it's probably for me, again, I work at Twistlock. We have, again, Claire is a good vulnerability scanning tool. Obviously, as a commercial product, would, I hope, provide more value and more information. But yes, you can push to Grafeas anything you want. I pushed from Twistlock, but again, because it's uniform, because it's a uniform API, you can, any tool can push. And it's not only vulnerability data; it can be anything. It can be anything, it's threat data, or not necessarily security data. Anything you want to do to ensure that only stuff that you trust are deployed inside production. But again, Twistlock is good. Sorry. That's about all. That answer your question?
Thank you.
Yes, question?
You talked about future extensions to the policies that you could do. Does it currently, or is it planned to check image signature? I mean, you mentioned that as a possibility, but is that something it does today, or is that roadmap, or what's the status of checking an image that's been signed by, let's say, a trusted certificate authority?
Great question. So it is possible to do it now. It's not implemented. And also, if you'd like to take it further, right, then you'll probably want to add that step into the Grafeas metadata itself, where it allows you to do that kind of verification. OK, one more minute, one more question. Let's see. Yes, you on the left side. My left side, anyway.
Yeah, I'm just curious what would be the ownership or the responsibility between, let's say, Twistlock Defender, which pretty much does a little bit of that, like making sure the image is signed, or CV and things like that, and where Kritis. So where do we draw the line? Which one should actually be responsible for doing that?
Again, this is the beauty of open source. Like you can use this. Again, it's not a commercial tool. If I were a bank, like I would buy a security product that does the entire stack and everything. If you have your own cluster or you're a small company, you can use open source. You can combine tools together. It depends. Like again, we see customers that run like on crazy clusters. They have tons of security tools, tons of products. This is just like another option to do that. Okay, but again, commercial products are good. They give you a whole suite like Twistlock. But again, there are like sometimes you use a commercial tool, sometimes you use open source tools. It really depends on the use case and exactly what you want to achieve. So this is just like a general answer. But Twistlock does similar things.
Well, thank you all so much for excellent questions, and thanks for coming to the talk.